Hello and welcome to the section 3.2 lecture today for Algebra 1 Part 1. We are taking a look today at some fractional one-step equations. So the main focus is going to be just one-step equations, but we are going to have some fractions involved. So let's get right into it and take a look. So for starters, remember that when we add or subtract fractions, we need to find common denominators. All right, that's a necessity, is that we need to find common denominators. And I'm probably going to throw in there like, going from mixed numbers to improper fractions, if that comes up. All right, so let's go ahead and see what this might look like. So in this first one here, I have x plus 3/4 equals 5/4. My job to solve this equation is to subtract 3/4 from both sides. Okay, now in this subtraction problem here, I would need common denominators, which I do already have. So that's going to make life a little bit easy. 5/4 minus 3/4 is going to be 2/4. And we can simplify that to be 1/2. So we get x is equal to 1/2. Excellent. Next one, I have x minus 1/2 equals 1/4. So I want to undo, undo that subtraction. We're going to add 1/2 to both sides. Now, just looking ahead, I know that I'm going to need 1/2 and some number of fourths. Since that's pretty easy to do, I'm going to say plus 2/4, because 2/4 is equal to 1/2. Okay, that one I would typically take care of just like that. Then in adding that 1/2 to both sides, on this side it cancels out just like the 3/4 canceled out over there. And we have x is equal to 1/4 plus 2/4, 3/4. All right. The next one, I've got 1/2 being added to x, so I'll take 1/2 away from both sides. And this one, I'm going to do a little bit of work on the side. So I've got 1/5 minus 1/2. And I want to come up with common denominators. I can turn them both into tens pretty easy. 1/5 would be 2/10. 1/2 would be 5/10. So we get 2 minus 5, which is negative 3/10. So x is equal to negative 3/10. And it's just that easy. Go ahead and pause the video and give these three a shot. They're pretty similar to the ones that we just did, but I want to see if you can do them. Hopefully you had a chance to get those done. Let's take a look at how you did. This one, since it's a negative 1/3, I need to add 1/3 to both sides. Add 1/3. And that's going to cancel that out. I'm going to get x is equal to negative 4/3 plus 1/3 is going to be negative 3/3, which is equal to negative 1. This next one, again, I've got a negative 1/5, so I'll add 1/5. And those cancel out. I have 1/2 plus 1/5 this time, which is similar to one that I just did, but I subtracted them then. So that's the same as 5/10 plus 2/10. And that's going to give us 7/10. And so we can just say that x is equal to 7/10. and we're good to go. This one, we should have added 1/8. Add 1/8 to both sides. And I do need common denominators. I need 1/4 plus 1/8. Well, I can turn them both into 8s. And that would be 2/8 plus 1/8, which is 3/8. So x is equal to 3/8. Okay. We got 6 more of these. Got plenty of problems to practice on. Some of these have some mixed numbers that we've got to deal with. So I'm just going to rewrite the equation without mixed numbers. 3 times 1 is 3, plus 1 is 4, so that's going to be 4/3 minus x is equal to -2/3. This one's a little bit tricky, okay? And you want to pay attention to how this works. The 4/3 is technically positive. The x is the thing that's negative. So this is a little bit more like almost a two-step equation. I do have to subtract the 4/3 since it's already positive. I need to subtract it. And when I combine these, I'm going to get, let me look here, I have -x is equal to -2 minus 4/3, -2/3 minus 4/3, which is -6/3, which is actually -2. But this says that -x is equal to -2. So I do have to get rid of that negative. And if -x is equal to -2, then positive x is equal to +2. Or you can think about the technical way is to divide a -1 on both sides. Okay, that would be how you would solve that. But again, that one is a little bit different. There's weird things that happen when you're subtracting x. Okay, let's look at the next one. We got some mixed numbers. I want to write them as improper fractions. 3 times 2 is 6 plus 1 is 7, so that's 7/2. 2 times 3 is 6 plus 1 is 7, and I have 7/3 plus x. I want to subtract 7/3 from both sides. And that's going to cause me a little bit of extra work. I have 7/2 minus 7/3. And I'm going to turn both those into 6s. To turn 2 into 6, we multiply by 3. So 7 times 3 is 21. To turn 3 into 6, I multiply by 2. So 7 times 2 is 14. And kind of funny on the answer we get, 21 minus 14 is 7/6. So we end up with another 7 as our answer. So we get that x is equal to 7/6, and we're good to go. Okay, this one I've got 1/2 that I want to turn into an improper fraction. 2 times 1 is 2, plus 1 is 3, so that's 3/2, and that equals 4. So to do this one, I want to add 3/2 to both sides. Okay, and if I look at 4 plus 3/2, 4 is actually going to turn into 8/2 plus 3/2. So 8, oops, I don't know why I wanted that to be an 8 so bad. That's just halves. 8 plus 3 is 11, so we have 11/2. So x is equal to 11/2. Do me a favor, pause the video again and try these last 3. Hopefully you had a chance to do that. Let's go ahead and take a look at these. So hopefully we got 11/5 here plus x is equal to 1/2. Okay. We want to take the 11/5 away. And we're going to have to find some common denominators again. X is going to be equal to, let's turn them into tens. 5/10 minus 22/10. 5 minus 22 is going to be a negative 17. So x is going to equal negative 17 over 10. Next one, I do want to turn it into improper fractions first, so I'm just going to rewrite. 3 times 6 is 18, plus 1 is 19. So that's 19/3. And I want to add that to both sides. And with a 3 and a 4, I think I'm going to turn them both into 12s. To turn 4 into 12, I multiply by 3, and negative 3 times 3 is negative 9. To turn 3 into 12, I multiply by 4, and here I've got 19 times 4, which is 76. Okay, and just to double check, so that's pretty much 76 minus 9 should be 67. Sorry that you can't see that, but that's okay. 67 over 12. Okay, the last one we have here, 3 times 5 is 15, plus 2 is 17. 17 over 3 plus x. 2 times 2 is 4, plus 1 is 5 halves. Take away the 17/3. Take that away from both sides. And we've got a little bit of work to do. Let's turn them both into 6s. 2 times 3 is 6. 5 times 3 is 15. 3 times 2 is 6. 17 times 2 is 34. Okay, and just to check that one as well, that's 15 minus 34 is negative 19. Calculator's over on the other screen. I just didn't want to move it. Negative 19 over 6. Rough looking 19. Okay, now it's worse. There we go. Okay, let's take a quick look at the back side. I think it'll be a little bit nicer. This side, there were a lot of problems, but we needed to get that practice. On the back, we're talking about multiplying and dividing fractions. That's what's going to be involved in these ones. To multiply and divide fractions, for multiplication, we multiply straight across. For division, we keep change flip. Okay, so we will never divide fractions. We want to think about multiplying them. Okay, so let's go ahead and put that into place here. These ones, I'm going to treat them a little bit differently than how they're written, but it is the exact same thing. So in a problem like this, where I see, I'll do both of these problems different ways, just to let you kind of pick the one that you'd rather do. So for the first one, I think of this as 5 times x divided by 3. And I want to undo what's happening to x sort of backwards. Okay? If I knew what x was, I would multiply it by 5, and then I would take that answer and divide it by 3. So I'm going to undo the 3 first by multiplying by 3. Okay? And that's like multiplying by 3 over 1 gives me 5x equals 1 times 3 and 2 times 1, so 3 over 2. And then to undo the dividing by 5, the multiplying by 5, I'm going to divide. And that's kind of weird to think of over here, to divide by 5, because I keep change flip. So it really turns into the 5's cancel, that's fine. 3 over 2 times, instead of dividing by 5 over 1, I'm going to multiply by 1 over 5. And so that's going to give me 3 times 1 is 3, 2 times 5 is 10. So we get 3/10. Okay? And that's one way to look at it. And that's a pretty decent way. Okay, there's another way to look at a lot of these, though, that can really speed things up quite a bit. Let's use that idea on this one. And that is, anytime I have just multiplication and division on a side, I can kind of choose what order I want to multiply and divide. Right? Just like on this one, I thought of it as 5 times x and then divided by 3. I could think of it just as easily as 5 divided by 3 and then times x. And I'm going to rewrite that to where that's a little more clear on this one. I'm going to say 3 over 7 times x equals negative 2 over 7. And now the fraction 3/7 is being multiplied by x. So I have a fraction being multiplied, so we would divide, but we don't divide fractions. So I'm going to multiply by the reciprocal. So I'm going to multiply, let me back up and switch colors. I'm going to multiply by, it still has to be a negative, and I just put the negative in the top, but 7 over 3. So I'm going to multiply by negative 7 over 3. And what that does, we love to cancel things out when we're solving equations. The 3 and the 3 cancels, the 7 and the 7 cancels, and the negative cancel. So everything over here cancels out except for the x. I'm left with just the x. And then I can even do some cross-reducing over here. 7 and 7 cancel. And I like to make sure that I write this as negative 1. Okay, maybe block off more of that. And this is just a 1 down here. Negative 2 times negative 1 is 2. And 1 times 3 is 3. Okay, and that one's a little bit tougher of an example to really get the first impression of that method because of the negative and because there were some other things that canceled out. Kind of made it nice, kind of didn't, right? Next one, this isn't really a fractional problem, even though it's written as 1. It's just x divided by 3. So we can cancel out those 3's, and I get x is equal to negative 12. And there we go. Okay, so in any of these, I really encourage you to think about rewriting it where it's a fraction times x. And then also on this one, I hate that there's a negative down there. So I'm going to treat this as negative 3/2 times x is equal to 4 times 2 is 8 plus 1 is 9/4. Multiply both sides by a negative 2 over 3, multiplying by its reciprocal, and it is a negative. And so the 3's cancel, the 2's cancel, the negatives cancel, just leaves x equals, I can do some cross-reducing if I want to. Let's look at what happens if I don't. If I don't, I have 9 times negative 2, which is negative 18, and 4 times 3, which is 12. The only issue is that both those numbers are multiples of 6, and so I can reduce them by 6. Negative 18 divided by 6 is negative 3. 12 divided by 6 is 2. Negative 3 over 2. Okay, let me rewrite this one as well. I have 7 times 3 is 21, plus 1 is 22. So I have 22 sevenths equals, I'm going to rewrite this as 2 times 5, or 2 over 5 times x. Sorry about that. I'm going to keep change flip here, multiply it by 5 over 2. Multiply it by 5 over 2. I'm going to do a little cross-reducing. There's 11 2's and 22. 5 times 11 is 55, and 7 times 1 is 7. So we have 55 over 7 is equal to x. Look at the next one. It's kind of written perfect for me. I'm just going to multiply by the reciprocal. 3's and 4's cancel over there. I just get x is equal to, I can even do some cross-reducing. 4 on top, 2 on bottom. 1 times 2 is 2, 1 times 3 is 3. So we have 2/3. Last 3 problems. I'm just going to try to get through them a little bit quicker. Make sure there's no 911 happening at the house. Multiplying by negative 2 over 1 cancels all that stuff. We get x is equal to 4 times negative 2 is negative 8, and 5 times 1 is 5. Multiply by the reciprocal. Eights cancel, 9's cancel. X is equal to 1 times 9 is 9. 3 times 8 is 24. And that one's done. See, these ones are nice. Those ones where we had some negatives involved. Those ones are a little tougher. Next one, 2 times 4 is 8 plus 3 is 11. So that's 11/4. And 5 times 2 plus 1 is 11. So 11/2 x. Multiplied by the reciprocal, 2 over 11. Multiplied by 2 over 11. This one, a lot of stuff cancels. So over here, on this side, everything that we want to cancels, and we have x over here. On this side, the 2 and the 4 turn into a 1 and a 2, and the 11s turn into a 1 and a 1. So I've got 1 times 1 is 1, 1 times 2 is 2. So just 1/2. If you didn't think, if that cross-reducing is a little bit too much, think about what the numbers were. 2 times 11 is 22. 11 times 4 is 44. So I had 22 over 44, which would reduce to 1/2. That'll be it. Right, any questions you have over on the left, make sure you ask those when you come to class. Otherwise, I hope you have a great day, and we'll see you in class.